Okay, here we go on Chapter 9 test review. Remember, your test on Chapter 9 will be very similar to this review, so it's very important to understand every problem and not just get it finished. The first set is asking about questions pertaining to finding the inverse of a function. Remember, the inverse of a function can be solved two different ways: setting up a grocery list and then doing the opposite, or by switching the x and the y and then solving. I particularly like to set up the grocery list and solve that way, but you don't have to do it my way. If you don't like it with the grocery list method, go back and review the other method. All right, so the first one here, I'm looking at what happened to x in the function number 1. Well, if I were to list this according to PEMDAS or GEMDAS, I'd have to list the multiplication before the addition. So I think my list is basically, I took x, I timesed it by 5, so my first thing I did is multiply by 5, and then the next thing I did is I took that x and I added 1. Now I'm ready to do the opposite, so I'm ready to write my answer. I'm going to write f negative 1 of x equals x. I always start with an x. And then I'm going to start from the bottom of my list, work my way up, because I need to do the opposite. So the opposite order of which I do things and the opposite operation. So starting at the bottom, instead of adding 1, I need to subtract 1. So I've done that. And then instead of multiplying by 5, I need to do the opposite of multiply, which is divide by 5. So everything there needs to be divided by 5. Let's look at our possible answers. Is that one of our answers? Well, it is right there, so we know we got it right. Make sure you put your answer on your answer line over here. All right, next one, number 2. Let's list what happened to x. First, I need to take a look at, this one has GEMDAS going on, or if you like PEMDAS better, that's fine. There is a grouping symbol. There is a group of numbers here. So we have to discuss what happens in the group, because this takes precedence over the multiplication by 2. So that means inside this group, the first thing I did to x was I added 4. Now I've taken care of the group. There is no exponents, so I can talk about this multiplication next, which was multiplying by 2. Now I'm ready for my answer, so I'm going to go ahead and write x, and then instead of multiplying by 2, I'm going to divide by 2, and then instead of adding 4, I'm going to subtract 4. Okay? Another way to write this, x divided by 2, well, isn't that just half of x? Divided by 2 is the same as half. So if you were to write 1/2 x, I claim that that's the same as that. So let's look at the top, see if we have those options for our answer. And 1/2 x minus 4 is in fact right there, so that would be the answer to number 2. Let's take a look at number 3 then. Again, I like the list method. You don't have to do the list method, but I think that's my favorite. I think it's a little bit more fun. Let's list out what happened to x in this problem. So here's my x. The first thing I did was multiply by 2. I am writing the multiplication before I talk about the addition because I'm following the order of PEMDAS or GEMDAS. Multiplication comes always before addition, so that's written first. So I multiplied by 2, and then the second step I did was I added 3. Now I'm ready to write the opposite, so I'm going to go in the opposite order. Here's my x. I'm going to start at the bottom and work my way up, but instead of adding 3, I'm going to subtract 3, because that would be the opposite or inverse. And then I'm done with number 2, so I'll go back to 1, and instead of multiplying by 2, I will divide by 2. So x minus 3 over 2. Let's see if we have an option like that. And we do. It is right here, x minus 3 over 2. So that answer needs to go in for number 3. Let's go on to number 4. Ooh, we've got a square root going on. But more importantly, before the square root, we have a grouping symbol, or the P or G of GEMDAS. There is a group, so here's the group. And inside that group, what did I do to x? I subtracted 2. Notice I talk about this subtraction, even though it's technically the last thing that I would normally talk about in GEMDAS or PEMDAS, but it's within a group, so that just made it first priority. So now that I've talked about all the things that happened in the group, I can explain the exponent. So the second thing that happened to x is it got squared. So that means my answer is going to start with an x, and instead of squaring it, I'm going to square root that x, and then instead of subtracting 2, I'm going to add 2 to that. Notice the 2 is not within, not underneath that square root, so that means that our answer would most likely be this one. The 2 is not inside the square root, so that is what goes for number 4. And last but not least, number 5. Let's talk about what happened to x. First, I need to express there's no groups, so I need to talk about that exponent first and foremost. I first and foremost took x and I squared it. Then I multiplied by 4. And last but not least, I subtracted 1. So for my answer, I'm going to take x, and I'm not going to subtract 1, but I'm going to add 1. And then I'm not going to multiply by 4, but I'm going to divide by 4. And then to that entire thing, I'm not going to square it, but I'm going to square root it. I got a few questions on this one. This answer right now, as is not written up above. But if you notice, I am square rooting both this top stuff and the bottom stuff. Do you know the square root of either the top or the bottom? I know the square root of 4, so isn't this the same as, okay, I'm not going to touch the top, I don't know the square root of x, so I'm just going to leave that alone, but I do know the square root of 4, isn't that just 2? So I do think that this answer is listed, and I know that I don't usually make you go further and actually start simplifying these inverses, but if this is a matching one, you'll have to be able to pair answer that you got to the simplified version if the simplified version is the only answer listed in the answer box. All right, let's move on to some questions. It says we have a little multiple choice question. For the equation f, which of the following statements is true? Part A is saying if I plug in 0 for x, I should get 3. Well, let's check that out. Let's just test it. If I plug in 0, then this function would read 0 squared minus 4 times 0 minus 3. Well, both of these things would just become 0, so I have 0 minus 3, but 0 minus 3 does not equal 3, it equals negative 3. So therefore, I think A is not correct. Let's try B. If I plug in 2, I'm hoping to get 13. Let's try it. I'm going to do 2 squared minus 4 times 2, and then minus 3. Well, 2 squared is 4, minus, this would give me 8, minus 3. 4 minus 8, well, let's see. I can already tell you this is not going to be 13. 4 minus 8 gives me negative 4, and then minus 3, that gives me negative 7. Definitely not 13, so B is incorrect. So let's take a look at part C. If I plug in 5, that means I'm doing 5 squared minus 4 times 5 minus 3. Well, 5 squared gives me 25. Negative 4 times 5 gives me negative 20, and then minus 3. All right? This guy gives me 5 minus 3. Oh my goodness, that is 2, which is what it said it should be. So yes, it's true. If I plug in 5, I do get 2. So C must be the correct answer for number 6 here. The next one, number 5. If I take a function, I plug in 5, I get some random answer called star. If I take the inverse of that function and plug in star, then basically it's saying I'm going backwards. Inverse is backwards. So if 5 gave me star, then what would star give me? Go backwards. Wouldn't it just give you 5? There's nothing to do here. There's no math to do. Don't change the sign. Don't make it a fraction. Don't change the sign and make it a fraction. It's literally just 5 gave you star, so star would give you 5. Pretty easy right there. That one is part B. Our answer is B. A lot of kids get confused on that because I'm using a star and not a variable. It's just the same thing, okay? Number 8 is a twofer. I'm asking you 2 questions in one, so it's really asking you 2 questions here. It first says find f of 3, so I need to plug 3 into this function. I'm going to take 2 and times it by 3 and square it and subtract 4. So let's follow PEMDAS here. I need to first do the exponent, which would give me 9, but then I need to times it by 2 and subtract 4. Well, 9 times 2 is 18 minus 4. 18 minus 4 would be 16. Nope, I'm sorry. 18 minus 4 would be 14. There we go, math. So that means when I plugged in 3, I got 14. So that's part of the answer. And then it asks, okay, well, what would the inverse of 14 be? So it's the question just like number 7. If I plugged in 3, I got 14. So if you plug in 14, what would you get? Well, that would just be 3. It's just going back and forth. So if I plug in 14 into the inverse, that means I should get 3 because 3 gave me 14 in the function, so 14 should give me 3 in the inverse. They're partners like that. Technically, these are both answers to number 8 because it technically asked you 2 different questions there, so be careful. On the next page, we're doing some graphing. We have 3 types of graphs on this test. We have straight lines, parabolas, and absolute value v's. All 3 of these are very easy to graph. First off, the straight line, you're going to use the y-intercept first. Start at your y-intercept, your b. So that's on the y-axis at -2. Then from there, I'm going to follow my slope. It looks like it's -7/4. So I could either write it like that, or I could say 7/4. You'll notice that both of these options, slopes, are on the same line. What I mean by that is if I start at my y-intercept of -2, and then let's try to go down 7. That would be 1, 2, 3, 4, 5, 6, 7. That's way off my graph. But then it would go +4, so that would be somewhere over here. If I pick this version instead and go up 7 because it's positive, 1, 2, 3, 4, 5, 6, 7, and then -4, so left 4, that would be on the same graph as the one that was off the graph over there. Since this is an equal, I can go ahead and connect these dots with a straight line and some arrows. That's all there is to number, what is this? It doesn't have a number. Number 9, technically, I guess. All right. The next one, let's think about what this is going to look like. It's definitely a parabola, so it's going to be a U-shaped figure. It looks like it's also negative, so it's going to be a downward-facing parabola. Where is my vertex? If this is in vertex form, your vertex is staring you in the face. Remember, switch the signs. This is going to be -3, comma, leave the sign, 4. We switch the sign on the x, we leave the sign for the y. So -3, comma, 4 would be right here for the top of my parabola. It's going to open down. Now, in my class, I required you to graph 5 points, which means we're going to have to plug in some values here. Let's think about smart values to plug in. So right now, I'm at, my x value is -3. What if we try, say, -2 and then -1 and just see what happens as I'm going this way with my parabola? I'm going to make a little xy table. If I plug in -2, again, I've picked -2 because it's literally the next value over from my vertex. So I'm going to plug in -2 for x. That means this x is going to become -2. I'm going to leave everything else the same. So I left that negative outside. I'm leaving the 2 alone. I'm going to square that and add 4. I honestly plugged this into my calculator to see what I get, but you can certainly use your brain. You end up getting 3. In other words, when I plugged in 2, or when x is 2, my y value is 3, so my next point is right here. I can use the fact that parabolas are symmetric to copy that point on the other side of the axis of symmetry, which goes right through this vertex point. So I currently have 3 points in my parabola. I just need 2 more somewhere, and I can connect the dots and have 5 points total like I'm supposed to. So I know what happens at -2 for x. Let's try -1. If I plug in -1, I'm going to do -1 plus 3 squared plus 4. And if you plug this into your calculator and use the parentheses just as written, or, of course, you could use your brain, you end up getting 0. So that means at -1 I got 0, so that means at -5 I must get 0 to keep this parabola symmetric. Now that we have them all, go ahead and connect these. Make sure it's a rounded shape so it does look like a U and not a V. Okay? The next one is going to be a V, and I can tell you that right now because it has absolute values. There's no sign out front, there's no negative out front, so that means it's going to be opening up. And this number out here that's hiding is really just a 1. Remember, this number represents the slope. It looks like my M, or my slope, is going to be up 1 over 1 in general. So I have a 4, 1 here for my H and my K, which means my vertex is -4, 1. Switch the sign, leave the sign, -4, 1. So that means right here. And then as we stated before, my slope, the number out front, well, there is no number, so it must be a hiding 1. I'll go up 1 over 1, so here's my next point. Up 1 over 1. And you are allowed to do this for absolute values because you know it's going to be a straight line. However, that only gives me half of my V. Where does the other half come from? Well, symmetry, right? These guys are symmetric throughout the vertex, just like parabolas. So if I went up 1 over 1 to the left, you can start seeing the V form on the other side here. All right, let's talk about converting to vertex form. This is pretty simple. We've done this since chapter 5. We are working on completing the square. So I'm going to take y equals x squared plus 12x plus 32, and I want to turn this into a perfect square trinomial so I can do square root of the front, square root of the back, sine of the middle. Right now, this back number is not easily square rootable, so I would suggest that you get rid of it. You move it to the other side. He is not going to help us out very much, so I'm literally going to move him and make some room. That means on the left, I have y minus 32 equals x squared plus 12x. Now it's time to put your blanks in, and remember we have this little algorithm to fill in our blanks. Take the middle term, divide it by 2, which gets us 6, and then square that, which gets us 36. Now, if I add that to the right side, I must make sure I add it to the left side as well, which means that on the left now, take a look, I have 36 minus 32, so isn't that y plus 4 altogether equals this x squared plus 12x plus 36 business on the right. What you just did is you just created a perfect square trinomial. Don't you know the square root of this number? It's easily square rootable. So we can factor this using that cool shortcut, square root of the front, square root of the back, sine of the middle. So let's go ahead and turn this guy into a parenthesis, taking advantage of that shortcut. So the square root of the front goes in the front, so that's x. The square root of 36 goes in the back, so that's 6. The sine of the middle is positive, so there we are. Last but not least, let's move this 4 back to the back side of that parenthesis by subtracting it away, and I've got my y by itself equals x plus 6 squared minus 4. There is your vertex form. And now you can see that your vertex is right there looking you in the face. Remember, we switch the sign, we leave the sign, so it looks like our vertex is -6, -4. Let's go ahead and graph that point in the third quadrant there. 5, 6, 1, 2, 3, 4. Okay, I want to make sure I got it in the right place. All right, now from here, to finish our parabola, we still need those 5 points. So just like we did up above on this page, we're going to plug in a few values that are close to that vertex point, and you can use your calculator to make this go quickly. But basically, my vertex right now, it's at the x value -6. So let's try plugging in values close to -6, like maybe -5 and -4. If I plug in negative 5, then this equation would be negative 5 plus 6 squared minus 4. You can use your brain or go really fast with your calculator, and you'll find that that value is negative 3. So that means when I go left 5, I need to go down 3 to get my next point and his mirroring buddy on the other side of the axis of symmetry. Remember, the axis of symmetry goes right through the vertex, okay? So now we know what happens at negative 5. Let's see what happens at negative 4. So I'm going to do the exact same equation except negative 4 for my x. And that will give me a 0, which means at negative 4 I get 0, so that over here I get 0 as well. I have 5 points, so I can connect them using a rounded curved parabola, and there you have it. You can see here clearly that the axis of symmetry goes right through the vertex, so that means the axis of symmetry line is going to be x equals negative 6. A little reminder, the axis of symmetry is always the x value of your vertex. The direction of opening is clear to see, it opens up, and the zeros are the two places it crosses the x-axis. So that is at where x equals negative 4 and where x equals negative 8 for this problem. Let's do the same method for the next one over here. I've got the equation y equals x squared minus 8x plus 15. Again, this 15 is not easily square rootable, so I'm going to subtract him off to the other side. So I have y minus 15 equals x squared minus 8x. If I add my blanks in, remember, we fill in that blank by taking the middle term, dividing it by 2, which would be negative 4, and then squaring that answer. Well, negative 4 squared is positive 16. I'm going to add a 16 to both sides of the equation. So that means on the left side, I really have y plus 1 equals this stuff on the right side. Well, that stuff on the right side is really easily factored. We just created a perfect square trinomial, so take advantage of that and factor him using the shortcut. The square root of the front, the square root of the back, and the sign of the middle is minus. Okay, we're almost done. We just need to take this 1 and put him back to the back side of that equation by subtracting in this case. So that means my vertex form is y equals x minus 4 squared minus 1. So I have y equals x minus 4 squared minus 1. So my vertex is staring me in the face. I switch the sign, I leave the sign, so that's 4 comma negative 1. Let's go ahead and graph that. 4 comma negative 1 would be right here. And finally, I'm ready to, well, I think you could already tell me what my axis of symmetry is. My axis of symmetry is the line that goes right through that value, so x equals 4. We can see that here is my axis of symmetry, right through that value. Then to find my zeros, oh, well, the direction of opening, sorry, we can do that too. It opens up. We can already tell that before even graphing because I have a positive out front. Last, to find the zeros, that's just where does this guy cross the x-axis? Well, right now, I don't have any x-axis. I don't have any zeros because it's just one dot. So let's use maybe an xy table to plug some more values in. What values should we pick? We're at x equals 4 now, so let's maybe try, oh, I don't know, like, let's try 3 and 2. If I plugged in a 3, that means I would be taking 3 minus 4 squared minus 1, and that would give me 0, which would mean I'm right here and mirroring over there. And then if I plugged in a 2, for example, it would be 2 minus 4 quantity squared minus 1, and that would give me 3. So if I'm at 2, I'm up 3, so right here and mirroring over here. You can see my nice looking parabola. Most importantly, my zeros at 3 and 5. There we are.